So basically your अरे तुम में याद रखो उसको उसका काम करने दो. Okay, Rx value it is becoming 0. So how did it become 0? Basically we have equated the summation of fx equal to 0. Right? The equilibrium equation we have applied, that is your summation of fx equal to 0, and from that we got this value Rx equal to 0. Right? So we know that there are three equilibrium equations. What are they? Summation of fx equal to 0 and summation of fy equal to 0, and another is your summation of moment above any point equal to 0. Right? So for solving the unknowns, to finding the reactions, we can use all three equilibrium equations. And when we use this particular equation, that is summation of fx equal to 0, in that case we found that your Rax, this value is becoming 0. And now we are left with two more unknowns. What are they? That is, one is your Ray, another is your moment about this point A. That is the moment reaction. Right? So to calculate the moment reaction, again to calculate the unknown reaction, that is this one, we can use this particular equation. That is summation of fy is equal to 0. Right? So if we will be taking summation of fy equal to 0, then there are two forces. One is this is the known force, this is the applied force, right? And we are calling this as the shear force. Right? Another one is this reaction one. Right? Obviously when we are saying that summation of fy equal to 0, right, that simply means one will be along the negative y and another one is the along the positive y. That simply means this magnitude will be equal to that one. So from that we can conclude that Ray that is equal to P. Okay? Then another reaction is there, moment. Right? So obviously when I am trying to find out the moment about this point, right, then obviously there will be no moment due to this force. Am I clear? Shall I get any moment due to Ray about this point? ये point के about में इस force के कारण कुछ moment आएगा क्या? No moment, right? And there will be only moment activating due to this shear force, that is P. Right? That is why moment about A, that will be equal to P multiplied by this distance, homogeneity. That is that. That is P. Right? So here this is the moment about point A. Okay? So here there were two unknowns. Basically there were three unknowns. Out of them, when we use the fast equilibrium equation, that is summation of all these forces along x axis equal to 0, from that we got that Rax, that is equal to 0. Then we use the second equation, summation of fy equal to 0, from that we found out the value of Ray, that is equal to P. Then next we use the third equilibrium equation, summation of moment about any point that is equal to 0. So from that we found out the value of Ma is equal to P multiplied by A. Done? Okay. Next, we'll be trying to use this data to draw the shear force diagram. Okay? And shear force diagram we'll be trying to find out. We have to take the sign convention of the force. Right? So what is the sign convention over here? What we are going to do, we have to find the shear force at any cross section of the beam, maybe somewhat here or somewhat here or somewhat here, right? And the forces I have to consider from one side only. If I am to calculate the shear force for this particular cross section, we have to consider the forces which are there either in the left side or in the right side. Choice is yours. And obviously, because this is satisfying the equilibrium condition, whatever value you will be getting from the left side, that will be equal to the value of right side. Doesn't matter. So according to your convenience, you have to follow or you have to calculate from which side you have to find out the shear forces. Right? So suppose I am saying from here and I am trying to calculate the forces from the left side. Right? So and someone who wants to calculate maybe from the right side. So we have to follow some of the sign convention, and to remember that I am writing something RUN, right? RUN. So here R stands for right, U stands for upward, N stands for negative, right? If there is any force which is at the right of that particular section and it is in the upward direction, then that will be considered as the negative. Okay, so if you remember this one, then again you can just do reverse of that, right? Similar I can write right downward positive, left upward positive, left downward negative, right? So when I am saying right or left, it is with respect to that particular cross section where I want to find out the value of shear force, right? So if I want to find out the value of shear force at this particular section, then I may consider the left forces or I may consider the right forces, right? So if I am considering the right and the force is upward, then that will be considered as the negative, right? And if I am considering the left forces and it is in the upward direction, that will be considered as the positive. Similarly, if I am considering the left forces but it is in the downward direction, that will be considered as the negative. And if it is the right, the force is present in the right of this particular section and it is downward, then that will be taken as positive, right? So in this case, if I am talking about this section, let this is at a distance of x from point A, then if I am trying to find out, there is only one force, right? So there is no other force, there is only one force, that is RAY, right? So obviously I will be saying the magnitude is shear force का जो magnitude होगा, that will be RAY, but direction or the in which direction I need to plot, that is it is in the direction of upward, and for upward left upward we get as positive, right? So to draw the shear force diagram, again we have to take this length, then upward positive and magnitude is RAY, and RAY is equal to P, already we have calculated, right? So we have to take the magnitude, suppose this is P and this is positive, this is P, right? And this is up to what? Here if I am increasing the value of x, here this is the x, so when x is equal to 0, then also this is what? This is RAY. When I am increasing, then also this is what? RAY. Okay. Now let us try to find out. If I will try to find out from this direction, okay, from this right hand side, okay. So right hand side, suppose again at any distance, let y, this section is at a y distance from this end, right? And this is P is being calculated, right? So now again, so here which direction? It is right. We are finding the shear force which is right to this particular section, right? And this is downward, right? So right hand side and this is downward. So direction is positive, right? So here also at this end, I can say again this will be positive. At the value is P. And so from here at any section we will be considering, so you will be always getting the shear force value will be P. So this value will be P. So here we are taking shear force in y direction and this is the vertical length. Okay. So can you draw the shear force diagram? Well, any point load will be acting at the end of the cantilever beam. Any value will be given. P will be having different values, right? So you can draw the shear force diagram. Is there any problem? Now if I am trying to replace this particular point load with some different load, for that can you draw? Let us try to do it. Okay.